Fasting research is evolving rapidly, moving beyond early animal studies and short-term human trials to explore nuanced questions about timing, genetics, and individualized responses. While early investigations focused primarily on weight loss, insulin sensitivity, and metabolic markers, current research aims to clarify how different fasting strategies, such as time-restricted eating, TRE, alternate day fasting, and periodic caloric restriction, interact with an individual's chronotype, genetic background, and lifestyle to influence long-term health outcomes. These emerging studies promise to deepen our understanding of fasting as a precision nutrition tool and to identify the circumstances under which it produces maximal benefits. One major area of investigation is the optimization of fasting windows. Researchers are examining whether early, midday, or late eating windows produce the greatest improvements in glucose regulation, lipid metabolism, and energy utilization. Preliminary evidence suggests that aligning eating windows with natural circadian peaks, consuming the majority of calories during periods of highest insulin sensitivity, enhances metabolic efficiency, reduces postprandial glucose spikes, and supports fat oxidation. However, the optimal duration and timing of fasting likely vary among individuals, and ongoing trials are testing whether shorter or longer windows, for example, 6-hour versus 10-hour feeding periods, confer distinct metabolic or cardiovascular advantages. These studies will help refine TRE protocols, moving beyond generalized recommendations to personalized, evidence-based guidance. Calorie restriction continues to be a focal point of research, particularly in distinguishing the benefits of energy reduction from those of fasting timing alone. Scientists are exploring whether modest reductions in total caloric intake during fasting windows produce similar improvements in insulin sensitivity, inflammation, and lipid profiles as stricter fasting regimens. Early findings suggest that many benefits attributed to fasting, such as weight loss, improved glucose control, and cardiovascular protection, are primarily driven by energy balance rather than fasting per se, but fasting schedules may enhance adherence and reinforce circadian alignment. Future trials aim to clarify how combining controlled caloric intake with TRE or other fasting protocols can optimize metabolic outcomes while remaining sustainable for long-term practice. Chronotype, or an individual's natural preference for morning or evening activity, is another key factor shaping responses to fasting. Studies are increasingly exploring whether early larks benefit more from morning-centered fasting windows, while evening owls might experience improved metabolic outcomes with later feeding periods. By accounting for inherent circadian tendencies, researchers hope to identify personalized fasting schedules that align nutrient intake with internal biological rhythms, improving glucose regulation, energy utilization, and sleep quality. This focus on chronotype reflects a broader trend toward precision nutrition, in which meal timing is tailored to optimize both metabolic and behavioral outcomes. Genetic variation adds an additional layer of complexity. Differences in genes regulating circadian rhythms, insulin sensitivity, lipid metabolism, and appetite signaling can influence how individuals respond to fasting. Ongoing research is examining whether certain genetic profiles predict stronger or weaker benefits from TRE, alternate day fasting, or caloric restriction. For example, variations in clock genes or genes affecting insulin receptor function may modify postprandial glucose responses or fat oxidation during fasting periods. By integrating genetic information with lifestyle data, scientists aim to develop highly individualized fasting strategies that maximize health benefits and reduce potential adverse effects, moving fasting research into a truly personalized framework. Long-term outcomes are also under investigation, as most existing human studies are limited to weeks or months. Researchers are now conducting multi-month and multi-year trials to assess the impact of fasting protocols on cardiovascular disease risk, metabolic syndrome, cognitive function, and aging markers. These studies will provide critical insight into whether fasting contributes to sustained improvements in longevity, reduced disease incidence, and overall quality of life, beyond short-term changes in weight or blood sugar. They are also exploring how fasting interacts with other lifestyle factors such as physical activity, sleep, and stress management, highlighting the importance of integrating fasting into broader health routines. Another promising area involves mechanistic studies that examine how fasting triggers cellular repair processes such as autophagy, mitochondrial efficiency, and inflammatory modulation. Understanding how fasting influences these pathways in humans, particularly in the context of genetic differences, meal timing, and energy balance, will clarify the biological underpinnings of observed health benefits. Researchers hope that identifying specific molecular and hormonal responses will allow fasting protocols to be fine-tuned for maximum efficacy and safety. In summary, future directions in fasting research are expanding into sophisticated, personalized investigations that account for fasting windows, calorie restriction, chronotype, genetics, and lifestyle factors. These studies aim to refine our understanding of who benefits most from specific fasting strategies, how to align eating patterns with circadian biology, and how to sustain metabolic, cardiovascular, and cognitive improvements over the long term. The shift toward individualized, evidence-based approaches promises to transform fasting from a generalized practice into a precision nutrition tool capable of supporting energy balance, metabolic efficiency, and overall well-being for diverse populations. By integrating meal timing, genetic insights, and lifestyle context, future research will provide practical, actionable guidance that maximizes the health potential of intermittent fasting while maintaining flexibility and sustainability in daily life.